Lungfish, also known as salamander fish, are freshwater ripidischian fish belonging to the subclass Dipnoi. Lungfish are best known for retaining characteristics primitive within the osteichthyes, including the ability to breathe air, and structures primitive within Sarcopterygi, including the presence of lobed fins with a well-developed internal skeleton. Today, lungfish live only in Africa, South America and Australia. The African lungfish can sleep for up to 5 years without any sustenance. A fish that can hibernate for years without food or water could help scientists one day figure out how to put people into suspended animation to buy extra time during life-saving operations. The African lungfish can sleep out of water for 3 to 5 years without any sustenance, only to wake up when freshwater surroundings become available. African lungfishes burrow into the bottom of a riverbed or lake bed for their dry sleep, or estivation, sea dormancy. After burying themselves, they become encased in a mucus sheath that gradually hardens. Here they spend the dry season, during which the waterline becomes lower and the riverbed or lake bed finally dries out. The African lungfish generally digs in and insists in this manner, even if there is sufficient time to swim to deeper waters. African lungfishes also burrow into mud and head themselves under experimental conditions. They have been kept alive in such an induced state for more than 2 years. The South American lungfish also burrows into the mud in times of water shortage, but it forms no protective sheath. However, the Australian lungfish never buries itself in this manner. During prolonged estivation, African lungfishes may accumulate high concentrations of urea in the body. Studies have shown that a substance that inhibits the fish's normal metabolism induces the dry sleep of the African lungfish. Extracts from the brains of such sleeping fish inject D into rats have caused them to become lethargic. In addition, the body temperature of the rats falls 5 degrees Celsius, and the metabolic rate falls 33%. The day after receiving such injections, the rats stop eating. It is believed that the material responsible for this effect is a protein-like substance. A study showing what happens on the cellular level to the fish could help scientists one day induce a similar state in humans, making long-distance space travel and more advanced forms of medicine possible. The researchers claim that in the process they slow down their biological clock. During suspended animation, the fish don't eat or drink and produce no waste, sometimes for as long as 5 years. The researchers claim that in the process they slow down their biological clock, relinquishing the normal need for sustenance and surviving in a very low-energy state. This kind of suspended animation has always fascinated scientists because if it could be replicated in some form in humans, it could be induced in patients in critical conditions, such as gunshot wounds, in order to buy some extra